Hello students, welcome to UNOYA. My name is Rizwan. I hope you all are doing well. So let's continue our journey through the NCERT Class 10 Mathematics. Okay. In the last video, we have discussed the beginning of the third chapter. Okay. Third chapter of Class 10 NCERT Mathematics. Pair of linear equations in two variables. Okay. We have discussed about the introduction. Okay. Introduction of the topic, pair of linear equations in two variables. Okay. Now in this video we'll be discussing about the remaining topics. Okay. We will discuss few things. First one is we will discuss how to draw graphs. Okay. How to draw graphs representing pair of linear equations in two variables. Okay. And we will discuss how to solve pair of linear equations in two variables with the help of graph. Okay. And also we will try some more problems. Okay. We'll try some questions. That questions include forming pair of linear equations from word problems. Okay. Because some questions will be like that. Okay. You will get some word problems. Okay. Everything will be given in words. And you have to find or you have to create equations based on such sentences. Okay. We will discuss few questions like that also. Okay. So let's start. Yes. So we have the NCERT textbook. Yes. In the last video, we have discussed till this point. This is page number 26. Okay, page number 26 of NCERT Class 10 Mathematics. Yes. Now here we will begin with this example. Okay, example 1. You can see the question. Check graphically whether the pair of linear equations, you can see x plus 3y equal to 6. That is first equation. Second equation, 2x minus 3y equal to 12. Okay, is consistent. We have to check whether these equations are consistent or not. Okay, that is first one. Second one, if so, we have to solve them graphically. Okay, we have to solve them graphically. All right, so let's start. Okay, so first, yes, you can see the solution here. Okay, it's already solved here. You can see solution. Let's draw the graphs of equations 1 and 2. Okay, actually they are consistent. You can see from that graph. Okay, consistent equation means their graphs are touching. Okay, their graphs are intersecting. Okay, that is the meaning of consistent. They are not parallel lines, they are intersecting. Okay, so you can see it in the graph itself. Okay, you can see it in the graph. So the first step is we are drawing the graph of this equation here. Okay, we are drawing the graph. Okay, yes. So you can see, let's draw the graphs of the equation 1 and 2. For this, we find two solutions of the equations. Okay, we find two solutions of each of the equation. Okay, which are given in table 3.2. Okay, you can see. Okay, you can see two tables. Okay, table 3.2, it's divided into two tables. Okay, first table is representing the first equation, x plus 3y equal to 6. Okay, the first equation. Okay, this one, that is representing the first table. Okay, and the second table is representing the second equation. Okay, which is the second equation, 2x minus 3y equal to 12. Okay, second table is representing that equation. Okay, you can see x here and y equal to 6 minus x whole divided by 3. Why is it so? Because that is from the first equation. According to first equation, x plus 3y equal to 6. Okay, x plus 3y equal to 6. If you take this 3y to the other side, it becomes minus 3y. Okay, sorry, not minus 3y, you are taking x. Okay, take this x to the other side. Okay, take this x to the other side, it becomes minus x. Okay, it becomes minus x. Okay, so you will get 3y equal to 6 minus x. Okay, 3y equal to 6 minus x. That's why here you can see 6 minus x. Okay, 3y equal to 6 minus x. And if you take this 3 also to the other side, if you take this 3 also to the other side, it will move to the denominator. Okay, it will move to the denominator of 6 minus x. That's what you can see here, y equal to 6 minus x whole divided by 3. Okay, this is from the first equation. Okay, if you take x here, it becomes minus x, 6 minus x. And if you take this 3 to the other side, it becomes 6 minus x whole divided by 3. Okay, that is our y equal to 6 minus x whole divided by 3. Okay, yes. Similarly, move to the second table. Here you can see y equal to 2x minus 12 whole divided by 3. Why is it so? That is from the second equation. See the second equation. 2x minus 3y equal to 12. Okay, 2x minus 3y equal to 12. So what is the first step? Take this 2x to the other side. Okay, take this 2x to the other side. So it becomes minus 2x. Okay, it becomes minus 2. So you will get minus 3y only here. Okay, so minus 3y equal to 12 minus 2x. Okay, but if we take this minus also to the other side, that 12 minus 2x becomes 2x minus 12. 2x minus 12. That's what you can see here. 2x minus 12. Okay, so you will get the equation 3y equal to 2x minus 12. And if you take this 3 to the other side, it will move to the denominator. Okay, so you will get y only here. Y equal to 2x minus 12 whole divided by 3. Okay, simply if you take this 2x, this minus 3 to the other side, you will get only y here. So y equal to this side becomes 2x minus 12 whole divided by 3. Okay, yes. So these are the tables. Okay, in the first equation, y is equal to 6 minus x whole divided by 3. And in the second equation, y equal to 2x minus 12 whole divided by 3. Okay, now if you put each value for x, okay, if you put each value for x here, you will get the corresponding y value. Okay, here we are taking two values. Okay, here we are putting two values for x. So you'll get the corresponding y value. You can put any value actually. Okay, it's better to give symbol values. Okay, okay, if you feel some values are simple, if you feel some values yield better result, easier numbers, then try that value. It's true for any value. Okay, you can put any real number for x, you'll get the corresponding y. Okay, you can select any value. Okay, so if you find some values are easier, some values make your calculations easier. For example, 0. If you put 0, then it's very easy. Okay, so you can put prioritize such values. Okay, you can see first we are putting x equal to 0. What happened to this y, or what happened to this equation if you put x equal to 0? If you put x equal to 0, this x becomes 0. Okay, this x becomes 0. So y equal to 6 minus x whole divided by 3. That becomes 6 minus 0 whole divided by 3. Okay, what is 6 minus 0? Any number minus 0 is that number only. So 6 minus 0 means 6 only. Okay, so 6 divided by 3. What is 6 divided by 3? That is 2. That's why you can see 2 here. If you put x equal to 0, you will get y equal to 2. Okay, similarly, what happens if you put x equal to 6? If you put x equal to 6, this 6 minus x becomes 6 minus 6. 6 minus 6 is 0. 0 divided by 3 is 0 only. Okay, so that's why you get 0 here. Okay, similarly, see the second table. Here also, if you put any value for x, you will get the corresponding value for y. Okay, if you put 0 for x, if you put 0 for x, 2x becomes 0. 2 into 0, that is 0. So 0 minus 12 whole divided by 3. 0 minus 12 means minus 12. So minus 12 by 3, that is minus 4. So if you put x equal to 0, you will get y equal to minus 4. Okay, similarly, you can put x equal to 3 also. If you put x equal to 3, this x becomes 3. 2 into 3 minus 12 whole divided by 3. If you simplify, you will get minus 2. Okay, so these are the solutions of these equations individually. Okay, if you take this equation individually, equation 1 individually, these two solutions are there. You will find more solutions. There are infinite solutions. If you take only single linear equations in two variables, there are infinite solutions. But we have only one solution here if you consider both of them together. Okay, we are coming to that. Okay, so here if you take this equation individually, these two are the solutions. These two solutions are there. Not only these two are the not only solutions. We have more solutions. Okay, but these two are solutions. Okay, yes. If x equal to 0, y equal to 2. If x equal to 6, y equal to 0. Similarly, for second equation, if x equal to 0, y equal to minus 4. If x equal to 3, y equal to minus 2. Okay, and so on. Now let's draw the graphs. Okay, based on these points, we have to draw the graphs. Okay, we have to draw graphs of these equations. You can see two lines. Okay, two straight lines are there. These lines are representing graphs of each equation. Okay, this line is representing the graph of first equation. You can see x plus 3y equal to 6. Okay, this line, this straight line is representing the graph of first equation. Why is it so? For that, take this table. Okay, from this table, the points are clear. Which are the points? First point is if x equal to 0, y equal to 2. So 0, 2. Okay, so take 0, 2 points here. Okay, so you can see first draw x-axis and draw y-axis. To draw, these are the minimum requirements. Okay, we need one x-axis and y-axis. Okay, you can mark the points. the meeting point of the axis is 0, origin 0 0. On the right you have 1 2 3 4 etc. On the left you have -1 -2 etc. x-axis. Similarly vertically we have y-axis. In the middle you have 0. Going up you have 1 2 3 etc. And going down you have -1 -2 -3 etc. Okay, yes. Now the first point is 0 2. X is 0, y is 2. So which is the point? X0 means you should not go right or left. If you go right, x is positive. If you go left, x is negative. So should not go there. It should be on the y-axis. Okay, x equal to 0 means the point is on y-axis. Okay, then y equal to 2. Where is y equal to 2? This is y equal to 2. 1, 2. So this is y equal to 2. So on y-axis, take the point y equal to 2. So this is our first point. Name it as A, 0, 2. Okay, 0, 2. Okay, similarly, take the second point. Which is the second point? You can see here. If you put x equal to 0, sorry, if you put x equal to 6, y equal to 0. Take 6, 0. Okay, take 6, 0. Okay, take 6, 0. Yes, you can see. 6, 0 is the point here. This is the point 6, 0. Okay, because here the y coordinate is 0. Y coordinate 0 means the point is on x-axis. Okay, the point is on x-axis. Okay, so and the x coordinate is 6. X coordinate 6 means this point, 6 on x-axis. Okay, so this is our second point. Okay, 6, 0. So mark this point also. Okay, then draw a straight line connecting these 2 points. Okay, draw a straight line connecting these 2 points. That straight line is nothing but the graph of this equation. Okay, because this table is representing the first equation, x plus 3y equal to 6. Okay, so this straight line is based on this table. So this is the graph of our first equation, x plus 3y equal to 6. All right, similarly you can draw the graph of second equation as well. Okay, graph of second equation. For that, plot these points. 0 minus 4. X is 0, y is minus 4. This is the point, 0 minus 4. Okay, name it as P. Second point is 3 minus 2. X is 3, y is minus 2. Okay, x3 means here, y minus 2 means here. Okay, so 3 minus 2. This is the second point. Name it as Q. Okay, 3 minus 2. Okay, now draw a straight line joining these 2 points. Draw a straight line. That is the graph of the second equation. Okay, 2x minus 3y equal to 12. Okay, okay, yes. Now we can see at one point these two graphs are intersecting, right? You can see these two graphs, these two straight lines are intersecting at one point. So what is the peculiarity of these equations? What is the peculiarity of this pair of linear equations in two variables? They are consistent because it is intersecting. Okay, this is intersecting at the point 6, 0. So this point is actually the solution of our equation. Okay, you can see, plot the points 0 2, a 0 2, b 6 0, p 0 minus 4 and q 3 minus 2. We have done all this, okay, on graph paper, and join the points to form the lines a b and pq as shown in the figure. Okay, a b and pq. Okay, we observe that there is a point 6 0 common to both the lines a b and pq. Okay, 6 0 is common to both the lines, so the solution, that is a solution. Okay, so solution of the pair of linear equations is x equal to 6 and y equal to 0. This is the solution. Okay, x equal to 6 and y equal to 0. Okay, that is the given pair of linear equations is consistent. This is the method of solving pair of linear equations graphically. Okay, yes. So if you have any questions like this, in some questions directly you will get equations like this, but in some other questions you will find word problems. So the first step in such cases, in such questions, is you have to convert such word problems to equations. Okay, then solve it graphically. Okay, so next we will discuss that. Okay, we will discuss such questions. Okay, in such questions I will explain how to convert word problems to equation. Then you can follow these steps to draw graphs and finding the solution using graphs. Okay, yes. You have second questions, similar question here, that we will, this type of question we will discuss in the exercise part. Okay, so I'm not explaining it here. This is a word problem. Okay, this is a word problem. In the word problem, in the exercise part also, I will be discussing word problems. Okay, based on word problems, I will create equation. Okay, this question is same type, so we will discuss it in the exercise part. All right. Yes. So let's move to our exercise. Yes. Exercise 3.1. Okay, exercise 3.1, question number 1. Okay, you can see two sub questions under exercise 3.1, question number 1. You have two sub questions, first sub question and second sub question. Okay, yes, you can see form the pair of linear equations in the following problems and find their solutions graphically. Okay, that means for each of these cases, you can see two situations here, two sub questions. Okay, for each of these, you have to form pair of linear equations in two variables. Okay, and not only that, you have to solve it graphically, same as what we discussed here. Okay, here we have solved one pair of linear equations graphically, right? Same as that. Okay, yes. So the difference is here it's a word problem. We have to create equation. In the previous example, we were already given with the equation. Okay, we had to solve it only graphically, but here the equation is not given. So first you have to create that equation. Okay, yes. So let's see, how can we create equation? You can see the first one. This is the question. Okay, 10 students of class 10 took part in a mathematics quiz. Okay, if the number of girls is 4 more than the number of boys, okay, find the number of boys and girls took part in the quiz. This is the situation. Okay, it's only word problem. Some sentences are already given. We have to create equations based on that. Okay, what are the given details? 10 students of class 10 took part in mathematics quiz. Okay, there is a mathematics quiz. In that quiz, we have 10 students. There are 10 students participated. Okay, including boys and girls. Okay, then the exact number of boys and girls are not given. That's what we need to find the number of boys and girls. That is not given, but one more hint is given. One hint is this: total students is 10, total number of participants is 10. Okay, that is one hint. Second hint is this: if the number of girls is 4 more than the number of boys, that is a second hint. Number of girls is 4 more than the number of boys. So we have these two details. Okay, first one, which is the first one, the total number of students participated in the quiz is 10. What is second one? The number of girls is 4 more than the number of boys. So based on these two details, we have to create two equations. Okay, that means we have to create a pair of linear equations in two variables. Okay, yes, let's see. Yes, so this is the for the question number 1 and the first sub question. Okay, question number 1 and first sub question. Yes. Okay, question number 1. Yes, and first sub question. Okay, in the first question, it is given that what are the given details? The total, we have a mathematics quiz. Okay, the total number of students is 10. Okay, including boys and girls. That is the first detail. Which is the second details? Number of girls is 4 more than number of boys. Okay, so what is the first step? First step is we have to assign variables. Okay, we have to assign variables for each quantity. Okay, here we have two quantities. Here we have two numbers. First one is number of boys, second one is number of girls. Okay, so we have to assign two variables. Okay, because we are discussing about linear equations in two variables. Okay, so let's assign variables for each. Okay, first one is you can take x. Okay, you can take x as the number of boys. Okay, you can begin your answer as let x be the number of boys. Okay, let x be the number of boys. X is the number of boys. Okay, number of boys. And you can take y as the number of girls. Okay, x is the number of boys and y is the number of girls. Okay, x is the number of boys and y is the number of girls. Okay, now what is the first detail? First, according to first detail, the total number of students is 10. That means number of boys plus number of girls is 10. What is number of boys? That is x. What is number of girls? That is y. The number of boys plus number of girls means x plus y. That is equal to 10. Okay, this is the first equation. Okay, this is the first equation. You can name it as equation number 1. Now move to the second detail. What is the second detail given? Number of girls is 4 more than number of boys. What is number of girls? Y. What is number of boys? X. Okay, so if number of girls is 4 more than number of boys, that means y is 4 more than x. 4 more than x means x plus 4. That means y is x plus 4. That means y is equal to x plus 4. This is the second equation. Okay, second equation. Now we have created both the equation. Okay, this is the method of creating equations from the word problem. Okay, you have to assign variables for each of the quantities. Okay, and you have to apply the given details. Okay, now the next step is you have to solve this graphically. You can try it. Okay, I have already explained in the first example how to solve equations graphically, right? What you have to do, draw the graph of each equation. Okay, put 0 for x. That means here in the first equation, first put x equal to 0, you will get y value. Then put y equal to 0, you will get x value. Okay, then you will get 2 points. Then on the graph, plot these 2 points, draw in a straight line connecting these 2 points. That is a graph of this first equation. Do the same thing with second equation also. Put y equal to 0, you will get an x value. Then put x equal to 0, you'll get the corresponding y value. We have 2 points join to get the graph. Okay, then you will find on at one point these two graphs are intersecting. Okay, these two graphs you can see intersecting at one point. Okay, you have to take a graph paper and draw on it. That point of intersection is the solution. X coordinate of that point is the our x value, and y coordinate of that point is our y value. That means x coordinate of our point of intersection means number of boys, that is x value, and y coordinate is number of girls. Okay, so all of you please try it. Now let's move to a second question. Second sub question in the same question. You can see it's a different situation. This is the question. 5 pencils and 7 pens together cost 50 rupees, whereas 7 pencils and 5 pens together cost 46 rupees. Find the cost of one pencil and that of one pen. Okay, we have some pencils and some pens. Okay, this is the first case. 5 pencils and 5 pens together cost 50 rupees. Okay, the cost of 5 pencils and 7 pens, that is 50 rupees. That is the first case. With this case, you can form the first equation with two variables. Okay, now move to second case, whereas 7 pencils and 5 pens together cost 46 rupees. This is the second case. The cost of 7 pencils and 5 pens is 46 rupees. This is the second case. With this case, you can form the second equation. Okay, so first equation, second equation, you have the pair of linear equations in two variables. Okay, so what is the first step? Take the variables. Okay, you can take x and y. What is x? You can take x as number of pencils and y as the cost of one pencil, that is x. What we need to find, we have to find the cost of one pencil and the cost of one pen. That is a question. Cost of one pencil and cost of one pen. So you have to take that as x and y. Okay, so what is x? Cost of one pencil. What is y? Cost of one pen. Okay, then with the help of that, you can apply these situations. You will find two equations. Okay, so let's see on the first question and second sub questions. Okay, what is our x here? X is the cost of one pencil. Okay, cost of one pencil, that is x. And what is y? Y is the cost of one pen. Okay, cost of one pen. Now let's apply the given details. What is the first situation? You can see the cost of 5 pencil and 7 pens. Okay, cost of 5 pencils and 5 pens together, that is 50. Okay, if we have taken x as the cost of one pencil. If x is the cost of one pencil, what is the cost of 5 pencil? That is 5x. Similarly, we have taken y as the cost of one pen. If y is the cost of one pen, then what is the cost of 7 pens? 7y. Then if you add them, if you combine both of them, you will get 50. That means if you add 5x and 7y, you will get 50. That means 5x plus 7y equal to 50. That is the first equation. Okay, 5x plus 7y equal to 50. Okay, that is the first equation. Which is the second equation? This case, 7 pencils and 5 pens together cost 46 rupees. Okay, 7 pencil cost means 7x. 5 pens cost means 5y. Okay, so if you add them, you will get 46. Okay, so 7x plus 5y equal to 46. That is our second equation. Okay, so let's write each of these equation. First one, cost of 5 pencils and 7y. Okay, that is 5x plus 7y equal to 50. Okay, that is the first equation. Okay, rupees 50. Similarly, second case, the cost of 7 pencil, that is 7x plus 5 pen, 5y equal to 46. That is the second equation. Okay, that is second equation. Same way we got two equations. Okay, now you can apply the previous steps. Okay, solve graphs of each of the equation. Okay, from here put x equal to 0 first, you will get a y value. Then put y equal to 0 first, you will get the x value. Okay, you will get 2 points joined by a straight line. Do the same thing with this equation also. Okay, and you will find one intersecting point. Okay, find the coordinates of that point. X coordinate of that point will be the cost of one pencil, and y coordinate of that point will be the cost of one pen. Okay, so all of you please try that. Okay, yes. So this is the method of solving pair of linear equations in two variables graphically. Okay, first, if you have word problems, you have to create equation. You have to construct equations. Okay, then draw graphs for each equation, then solve it. All right. Now let's move to the second question. Okay, in the second question, on comparing ratios a1 by a2, b1 by b2, and c1 by c2, find out whether the lines representing following pairs of linear equations intersect at a point, parallel or consistent. Sorry, or coincident. Okay. Okay, we are given with three pairs of linear equations in two variables. Okay, three pairs of linear equations in two variables. Okay, and in each pair, we have to find whether the lines representing the following pairs of linear equations intersect at a point, or are they parallel or coincident. Okay, let's find each one. What are the peculiarities of each case? What are the peculiarities of each case? We have discussed in the previous video, right? I hope you remember that. I'm repeating it. If you have a1 by a2 not equal to b1 by b2, okay, if you have a1 by a2 not equal to b1 by b2, then in that case, what will happen? In that case, the lines are intersecting. Okay, intersecting. Okay, then second case. What is second case? a1 by a2 is equal to b1 by b2 not equal to c1 by c2. Okay, a1 by a2 is equal to b1 by b2, but that is not equal to c1 by c2. What will happen in that case? In that case, the equation, the lines are parallel. They are inconsistent. Okay, they are parallel. No solutions. Okay. Now, what is the third case? a1 by a2 is equal to b1 by b2 equal to c1 by c2. In that case, what will happen? In that case, the lines are coincident. Okay, infinitely many solutions. Okay, so you have to check for each one in each of these equations. Okay, yes. So we will discuss each one in the next video. Okay, we will discuss each one in the next video. Okay, so yes. Yes, so that's all about our this video. I hope everything is clear for you, and I hope all of you have enjoyed it. In the next video, we will solve some more problems. Okay, first is this question. Okay, I have given a brief introduction about that question, the second question. Okay, so based on that equation, based on that pair of linear equations, we will check whether they are coincident or parallel or intersecting. We will check that. Okay, that we will do in the next video. Okay, as a first question, then we will do some more questions. Okay, some more questions we will do. There is a word problem also. Okay, so yeah, thank you students. Thanks for watching. See you next time. Take care. Bye bye.